Hello, my lovelies. It's Miss Lloyd again, here talking about the powers of binomials. So binomial expansion is when we multiply out a power of binomial. So something like x plus 2 to some exponent. So say like 7. No one really wants to do that. So I'm going to show you guys a way to do this without having to multiply it out every time. So first I want to kind of play around with these binomials. So a plus b to the 0 power. Doesn't matter what a and b are in this circumstance. Whatever this is to the 0 power is going to be 1. Of course, unless it's 0, we're going to assume it's not. A plus b to the first power is just going to be a plus b. When we do a plus b squared, remember we're multiplying it by another a plus b. So multiplying that out, we would get an a squared plus 2ab plus b squared. Doing the same thing for a plus b cubed, so then we would have 2 of these that we're multiplying with that third. So if we were to multiply that out, we would have a cubed plus 3a squared b plus 3ab squared plus b cubed. And then a plus b to the fourth, we're multiplying all that by another a plus b. End up with a to the fourth plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the fourth. And then the last one that I'm going to do out, we would multiply all of that by another a plus b. We would end up with a to the fifth plus 5a to the fourth b plus 10a cubed b squared plus 10a squared b cubed plus 5a b to the fourth plus b to the fifth. So I hope some of you guys have kind of started to see a pattern here. So this pattern follows Pascal's triangle. So this here's Pascal's triangle, so we can kind of see here we started out with a 1, the same that we did in that a plus b to the 0 power. And then we had the 1 and 1, so like the a and the b. Next, our terms are 1, 2, 1. So the a plus 2ab, or the a squared plus 2ab plus b squared. So it had a coefficient of 1, and then 2, and then 1. Same with our third row here. We had 1, 3, 3, 1. Fourth row, 1, 4, 6, 4, 1. Here's our fifth row, again mirrors the same. And then if we were to go with 6, this would be the coefficients for the 6. Looks like a very pretty birthday cake to me, if you ask. So here there are 2 special rules when it comes to Pascal's triangle. Our first one is that every row starts and ends with 1. So we notice that each of these rows is starting with 1, each of these rows is finishing with 1. So they begin and end with 1. They come in the same way they go out. The second rule is that each of the other numbers is the sum of the 2 numbers above it. So what that means is we're taking, there's nothing above these ones, so 1 and 1 give us that 2. 1 and 2 give us this 3. That 1 and 2 give us a 3. 1 and 3 give us 4. 3 and 3 gives us 6. 3 and 1 gives us 4. 1 and 4 gives us 5. 4 and 6, 10. 6 and 4, 10. 4 and 1, 5. 1 and 5, 6. 5 and 10, 15. 10 and 10, 20. And then it repeats itself there. And then, so if I were to make the 7th row, I would start off with a 1. The 1 and the 6 would add to give me 7. 6 and the 5, or sorry, 6 and the 15 would add to give me 21. 15 and the 20 would add to give me 35. And then I have 15 and 20 again, so I have another 35. 15 and 16 would give me another 21. 6 and 1 would give me 7, and then we finish with a 1. Remember, start off the same as it finishes off. I also really love the symmetry of it. You just have to know the first half, and then you just repeat the second half. All right, so here, when we are doing these expanding, so instead of multiplying what a minus b out 4 times, it doesn't really seem like a good use of my time, especially since I know a quicker way to do it. So whenever we're doing this, one of the first things I want you guys to look for is the exponent. This is going to tell you which row of Pascal's triangle we're looking at. So we're going to find the 4th row of Pascal's triangle. So P triangle is going to be Pascal's triangle because I'm lazy and I don't like to write things out. So basically, whenever we did the 4th exponent here, all of the coefficients match the numbers in the 4th row of Pascal's triangle. So I'm going to use that. So triangle, I'm just going to list out all these numbers. I'm also going to create some space because I will be doing a little bit more of this later. So 4, 6, 4, 1. Don't just write them on top like really, really close to each other. We're going to spread it out a little bit. Next thing that I want you guys to look at are the exponents for my variables. So for, let's say the 4th, we started off with a to the 4th power, so that matches. Then it went a cubed, a squared, a to the 1st, and then the a was gone. So basically a to the 0 power. The b's went in the opposite direction. I didn't have a b, so this is like b to the 0 power. Then had b to the 1st, b to the 2nd, b to the 3rd, and finished with b to the 4th, which matches the exponent that I started with. So basically, when I start with my powers of a, I'm going to start with the highest exponent, which is the exponent we have, so to the 4th, and then I'm going to go down. So a to the 3rd, a squared, a to the 1st, and a to the 0. And then for my powers of b, well, in this case, negative b, I'm going to do the opposite. And when we do this, remember, negative b needs to be in parentheses. We're doing this exponent for the entire negative b. So it's going to go up to 1, and then negative b squared, negative b to the 3rd power, negative b to the 4th. So it should always end with the highest exponent, again, that 4. So now I worked at McDonald's and we had combos. So basically we're going to do a combo of all of these. So each of these columns, so columns go vertically, these are going to create each term using multiplication. So 1 times the a to the 4th times negative b to the 0 power, which is going to give us a to the 4th. Going to multiply all of this in. So 4 times a cubed times negative b to the 1st will give us negative 4a squared b. Multiplying all of these in, we have 6 times a squared. That negative b squared will cause it to become positive. So 6a squared, that should be cubed here, sorry. A squared b squared. And then here, b to the negative b cubed would leave it as negative, so we'll have minus 4ab, going to actually cube it this time. And then our very last term, that negative b to the 4th power will cancel out our negative, leaving us with positive b to the 4th. And then we're done. Next one, we're going through the same process. So I'm going to do it in a different color because using the same 4 colors is going to get on my nerves. So again, I'm going to look at the triangle row. So I'm looking at 3. Pascal's triangle, that's 1, 3, 3, 1. And then I'm looking at my powers of x. So again, we're going to start with the highest exponent of 3 and go down from there. And then for my powers of b, we're looking at negative 3. So I'm doing negative 3 to the 0 power and going up from there. And then lastly, I'm going to do my combo. So I'm multiplying everything in each of those columns. So I'm going to ration them off now and then do all the multiplication. And here we have our finished product. literally, because we're using multiplication. And when you multiply things, you find the product. I'm so funny. All right, so then here's our solution, and we're done. So notice here, I don't really see the Pascal's triangle as much as I did before, but it is still something that's going to be present. It's because we have that -3 in there. That's going to cause us to kind of lose this side of Pascal's triangle just by looking at it. So here's another example. It's going the same way as before, so if you want, you can hit pause. I'm going to fast track through this. It is a little bit of a longer process, but the process is exactly the same as we've been using. And there we have it, kids. So with this, you do want to be careful because I know a lot of my students, they like to distribute the exponents when they're not supposed to, and then they don't distribute them when they are supposed to. So whenever you're doing 2x to the 5th power, it's the 2 and the x that get the power of 5. So 2 to the 5th power gives us 32, and we're multiplying that with 3 to the 0 power, which is just 1, leaving us with that 32x to the 5th. So please, 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 please remember that you are multiplying 2 by itself 5 times when this is going on. All right, and then the last one that I'm going to go over with you guys. So here they have given me the first 3 terms. So I know my first term is this, second term is that, third term is this. They want us to write down the last 3 terms. So something that is really freaking awesome about Pascal's triangle is that the first 3 coefficients are going to mirror the last 3 coefficients. So the first 3 numbers in the row are going to mirror the last 3. So I know with the 15th row of the triangle, I don't have to know the rest of them. I just know it starts off 1, 15, 105. So then it's going to end 105, 15, and 1. I know this is how it's going to end. So I don't have to worry about this part. So this is the triangle. When it comes to my powers of x, remember we start with 15 and then we go all the way down to 0. So I know my last one is going to be x to the 0 power, x to the first, and then x squared is going to be the third to last. And then I know with my y value, it's going to go up. So I'm going to get rid of this so this stuff is a bit closer together. So I know the highest it's going to go is going to be the last term, so that's to the 15th. And again, it's going up as it goes over to the right, so it's going to go down as I backtrack. And then I can do my columns and multiply all the stuff together. So I end up with 105 x squared y to the 13th plus 15 xy to the 14th plus just y to the 15th. And then we're done. Ta-da! Working smarter instead of harder. And so that's all I have for you guys today. My students can find their homework on the LMS. Those of you who are not my students, please feel free to like, subscribe, send this to anyone who you think might need it. Again, we are in some rough times, so sharing, caring, spread the love.